Hi everyone, this is Miss Crute, and today we're going to be working on day 1 of solving polynomial equations. The goals for today are to solve by factoring and construct the graphs of the functions. So today we're going to explore a lot of different methods of factoring. Some are going to be review, some will be new, just depends. Two important things you have to know. Always get the equation equal to 0 first, and no matter what method you're using, you always check for a GCF first. So we're going to do a warm-up that's just a review of a factoring problem you've already worked on this year. So first thing I check, it's already equal to 0, so we're good with that. Now I want to look for a GCF. Looking at all of these, I can see all three terms are divisible by 2. So I'm going to pull out a 2, and I get 3x squared plus 11x plus 6 equals 0. I want to get rid of that 2 in the front, so I'm going to divide by 2 on both sides. So we get 3x squared plus 11x plus 6 equals 0. Now I'm going to use the split the middle or Batman method to solve this. So I need to multiply the 3 and 6, which gives me 18. Then I need two numbers that multiply to 18 and add to 11. I know 9 times 2 is 18. 9 plus 2 is 11. So I'm going to bring down the first term and the last term. And I'm going to split up my middle term into 9x and 2x. Now I'm going to pull a GCF out of the first two terms. So that's a 3x. Then I'm left with x plus 3. The GCF from the second set of terms would be 2. So then I'm left with x plus 3. My two parentheses match, which means that I did it correctly. So I'm going to pull these guys out as a GCF. So x plus 3, and then the leftover is 3x plus 2, and that equals 0. To finish solving, now that I'm factored, I can go ahead and use the zero product property. So x plus 3 equals 0, and 3x plus 2 equals 0. So if I subtract 3, I have x equals negative 3. And over here I need to subtract 2, so 3x equals negative 2. Divide by 3, and x equals negative 2/3. I went through that problem a little quickly because that is a review. We did that in the last unit. I just want to give you guys a little refresher. So something else we need to know is what is the relationship between the solutions of an equation and the graph of the function? What we know is that the solutions are the x-intercepts. And that is useful because then we can use when we solve to sketch the graph. So what we're going to do is plot the x-intercepts. We're going to plot the solutions as x-intercepts. And then sketch the graph. So let's do a quick sketch of the first one. So I'm just going to make a set of axes over here. Now we know one of the solutions was negative 3, so 1, 2, 3. The other one was negative 2/3, that would be here. Now we know this is a quadratic equation, so since it's an even power, both ends will face the same direction. And it's positive, so that means that the right end has to be up. And since both ends face the same way, we know that both ends go up. And there's our graph. So let's move on. So after we do each equation, or after we solve each one, we are going to sketch the graph. If you can't remember how degree and the sign affect the graph, you need to look back at your day 2 notes from this unit because that's where I'm pulling all of that from. Alright, so the first method is factoring a trinomial. This is just like what we did before with a little twist. The difference is that before we had an x squared and an x to the first power. Now we've changed it to an x to the fourth and an x squared. It's still going to have the same relationship because the first exponent is twice the second. As long as the first exponent is 2 times the second one, then we can use that same method. So since there's no number in front of the x, I'm just going to use the guess and check method. We want to split it up, so I'm going to make my parentheses here. Normally when this is x squared, we just have x and x. Since it's x to the fourth, it's going to be x squared and x squared, because if we multiply those, it equals x to the fourth. Now I need two numbers that multiply to 6 and add up to -5. That would be -3 and -2. Now I can use the zero product property to set this to solve. So I've got x squared minus 3 equals 0, and x squared minus 2 equals 0. Now I can solve each of them. So add 3, we get x squared equals 3, and I can square root both sides. So we get x equals plus or minus √3. And then we can add 2 to both sides. So x squared equals 2. Square root both sides. X equals plus or minus √2. Now that we have the solutions, we can graph the corresponding function. So what we're graphing is f of x equals x to the fourth minus 5x plus 6. So if I sketch my axes over here, now what you would want to do here is, if you don't know about what square root of 2 and square root of 3 equal, you would want to type those into your calculator. I know that those are both going to fall between 0 and 1, between 1 and 2, and I know that √3 is bigger than √2, so I'm just going to use that information to help me graph it. So for the first point, plus or minus √3, it's going to be about here and here. And then for plus or minus √2, it's going to be about here and here. Again, if you're not sure what those values are, just type square root of 2 into your calculator and square root of 3. Now to sketch the graph, this is x to the fourth. The fourth is our highest exponent, so I know that they are both end behaviors are going to be in the same direction, and since it is a positive leading coefficient, I know that the right end has to go up. So I'm going to start by drawing that, and then we know that this end is going to go up also. So to connect those middle dots, it's going to just be something like this. This isn't necessarily exactly what the graph looks like, but it gives us a pretty good idea of what it does look like. Alright, so let's go on to the next one. The next method is the difference of two squares. Again, this is a method we've done before. We just are putting a twist on it. We're going to raise the power of the exponents. Remember, here I've got the pattern for you of the difference of squares. So on this one, remember, first thing we check for is if it's equal to 0. This equation is not already equal to 0, so I need to subtract 36 from both sides. Then I need to check to see if there is a GCF. 25 and 36 don't have anything in common, so no GCF. Now, if I want to use the difference of squares pattern, that means that my first term has to be a perfect square and my second term, which they both are. I'm going to start by rewriting them as a term squared. So the square root of 25 would be 5, and the square root of x to the fourth is x squared. So 5x squared is the same thing as this. Those are both the same, just written differently. The square root of 36 is 6, so I'm just going to write that as 6 squared. So now if we compare this to this, it looks the same. We've got two terms that are squared with a minus sign in the middle. So now I can rewrite it using this pattern over here. So I have 5x squared minus 6 and 5x squared plus 6 equals 0. If that looks a little confusing, just remember that this is our A and this is our B, what's inside the parentheses. All right, now that I have it factored, I can set each parenthesis equal to 0. So I've got 5x squared minus 6 equals 0, 5x squared plus 6 equals 0. So I'm going to go ahead and solve those really quickly. This is something you should already know how to do. That's why I'm going through it really fast. And remember, you can always pause or rewind the video if this is too fast for you. All right, so there are my two solutions. I'm not going to rationalize them for right now because we're just using them to help us graph. So, important thing to notice is on the second one, we have an I. That means it's an imaginary root. We can't graph imaginary roots on our axes here, so those ones will not show up when we graph them. So, 1, 2, 3. All right, so again, if you want to know this value, you can punch it into your calculator. I know it's going to be a little bit over 1, so I'm just going to plot here and here. Even though this is an x to the fourth, we only have 2 points on our axes because one of the solutions was imaginary. So since we have an x to the fourth with a positive leading coefficient, we know that both ends behaviors are going to be going up. And since it's an x to the fourth, there's going to be another direction change in there, but it's not going to cross. We know that because it's an x to the fourth. If this root wasn't imaginary, it would cross again up here. But since it's imaginary, that direction change happens off of the axes. All right, moving on to our next method, the sum or difference of cubes. These are two new formulas, but they work kind of similarly to the difference of squares. So we are going to work on them. With the first one, we're already equal to 0 and there's no GCF. Now this would match with the sum of cubes formula. I'm going to rewrite each term as something cubed. So this would be x cubed, and 27 is 3 cubed. So now this matches our pattern. This is A and this is B. So I have x plus 3, I'm following this pattern up here, times, that should be an A cubed, sorry, that should be a squared, A squared minus x times 3 plus 3 squared. Ooh, that shouldn't be an A, that should be an x. Oh boy, sorry for all those mistakes, guys. So now I'm going to go ahead and simplify that second equation there. So I've got x plus 3 times x squared minus 3x plus 9 equals 0. This second one on the right, that will never factor any farther. You will always need to use the quadratic formula. And so since I'm running a little short on time, I would like you guys to finish solving and graph. And then I also want you guys to give number 2 a try. I think that should be pretty easy. I'll give you a hint. You're going to be using that second formula there. All right, the last method we need to go through is very similar to the Batman method. So we're going to factor by grouping. I'm going to group my first 2 terms and my second 2 and pull a GCF out of each. So the first one, I've got x squared times x minus 2. The second one, I can pull out a negative 9. So we've got x minus 2 equals 0. My 2 parentheses match, so I pull the matching parenthesis out, and I'm left with x squared minus 9 equals 0. Then if we looked at the second one, you'll notice that's a difference of squares, so that can actually factor further. So I'm going to have x minus 2 times x plus 3 times x minus 3 equals 0. I'm just about out of time, so I want you to finish solving and graphing this last one. Good luck.